بسم الله الرحمن الرحيم رب زدني علما.
Now the next thing we'll try to understand about the overlay networks. Now the overlay networks, the definition wise we can say it's a virtual network which is being built on the top of your underlay networks. Now what this exactly mean is, like in general, in the previous we have discussed something called underlay network. Like in the underlay network we are going to provide the connectivity, that's something we do, and then we'll be configuring all the links with an L3 links, and then we will be configuring some kind of routing protocol to provide end-to-end reachability, that is your underlay network. Now once we set up the underlay network, now when the traffic is being forwarded from one point to another point, it is going to use one specific path. So like let's say this is a path which is being used. So logically this path will be represented as your overlay network. So the overlay network is something can be described as a dynamic path. So which is going to be programmed by the controller. Again, which path it is going to use, that is again something decided by the controller. So we do have a controller, and this controller is going to instruct the devices or share its requirements or give some instructions to the devices depending upon which model you implement. So based on that instructions or based on that requirements, it is going to use a specific path, and that particular dynamic path which is being programmed by the controller, we call this as a virtual network or the overlay networks. So in the overlay networks, as I said, the SDN controller is going to control, which is going to decide what will be the forwarding path to be used based on the requirements or based on the dynamic policies. So for this overlay network to work, of course the backend, you must have an underlay network which is being built. Underlay means, remember, IP end-to-end reachability. Overlay means the actual path which is being used by the used between the two endpoints in your network. Now you can take a simple example to understand more better. Like you have a server 1 or maybe a PC A is trying to communicate with a PC B. Now the actual path which is being used is decided by the controller. Now we do have a controller here. Now this controller is going to have some kind of policy, and that policy says the traffic which is going between this particular these two devices, when they are trying to communicate between these two, should use this path depending upon the policy requirements. Like you can say the policy, you can say there is a quality of service policy where the communication between these two devices must have minimum of, let's say, 150 kbps of bandwidth, let's say. That might be the requirement. Or the delay between the two devices must be minimum this one. So there are some application requirements. Depending upon that, the controller is going to decide what will be the forwarding path used between any two devices. So again, we need to understand that the controller, the underlay network has to be built in order to provide the overlay network communication. Like the virtual path or the virtual network must have an underlying network, or the underlying network should be present. Now some of the examples we can use practically, like the concept of VRFs. If you take, now in the case of VRFs is a concept of having a virtual routing table for each and every customer. So physically this is the network which is being built by the service provider, but still each and every VRF or each and every customer will have a separate routing table. So there will be a separate path, or it looks like as if there is a separate logical connection between the customer A to customer A sites, as well as customer B to customer B, as well as customer C to customer C. So the MPLS VPNs or the VRF, they can be logically considered as an overlay networks. One more example, we can assume there is something called VXLAN. VXLAN stands for Virtual Extensible LAN. Now this is the same like your LAN connections. Like we do have something called VLAN. Now we know the concept of VLANs in general. Now VLAN is like you have a VLAN 11 user here, and we want the VLAN 11 users should be able to communicate with the VLAN 11 users here. So generally what we'll do is, let's say this is on switch 1 and this is on switch 2. We connect some L2 link, let's say L2 link, and then we configure something called trunk link, which is going to, so this is typically an L2 link, normal switching I'm talking about. And using the trunking concept, we can allow the users of one VLAN or the same VLAN to talk to the same VLAN over the trunk link. You know the concept of trunking again. But whereas the VXLAN, we are trying to do the same thing exactly. We are allowing the users of one VLAN, let's say VLAN 11 here, trying to communicate with the users of the VLAN 11 on the other side of your network. So this can be an IP network over something called L3 links. So we are allowing the LAN encapsulation. This LAN encapsulation is being done over the L3 network, which means we are extending the same concept of the VLAN over L3 network. So physically there is an IP network, but logically it looks like as if we have these users of the same VLAN are actually part of one single LAN or one single network.